Have you ever wondered if the clocks in your computer can behave differently on different cores? It sounds strange, but it's a question that many developers have. Today, we're diving into the world of time points and clocks in multi-threaded applications. I totally get it. When you're working with threads and trying to compare time points, the last thing you want is confusion over timing discrepancies. You're not alone in this. Many developers face similar challenges. Here's the specific question we're addressing today. One user asked, can clocks from chrono be different on different cores? They're curious about whether there can be significant differences in timing, such as lags or variations in speed. Sound familiar? Let's explore this together. So, what's the deal with clocks on different cores? The standard specifies that the clocks should be consistent, but in practice, there can be variations due to how threads are scheduled and how the hardware operates. Let's break this down. And stick around. At the end of this video, I'll share a crucial tip that can help you manage time points effectively in your applications. To address the user's question, we first need to understand how the standard library's clocks work. The user should know that the clocks from chrono are designed to be consistent across threads, but there can be variations in their behavior on different cores. Next, the user should consider the implications of using high-resolution clocks. The chrono high-resolution clock is typically implemented using the highest precision available on the system, but this does not guarantee synchronization across cores. The user should also be aware that the standard does not specify how the clocks should behave on multi-core systems. This means that while the clocks are designed to be high-resolution, they may not be perfectly aligned when accessed from different threads running on separate cores. Finally, the user can mitigate potential issues by using synchronization mechanisms. For example, they can use mutexes or atomic operations to ensure that time measurements are consistent when accessed from multiple threads. Fun fact, did you know that the concept of time in computing is often more complex than in our daily lives? In the world of multi-threading, time can be as slippery as a greased pig. Now let's look at the answers provided by other users. This user explains that clocks from chrono do not have processor affinity, meaning measurements can be taken from different cores. They note that any lead or lag in measurements is similar to other instructions and typically not detrimental. If timing precision is critical, they suggest considering specialized timing tools or CPU-specific instructions. Now let's see a response from a different user. This user highlights that on modern Intel CPUs, there are mechanisms to ensure uniform clock ticks across cores. However, the operating system plays a crucial role. For instance, some Linux kernels use the timestamp counter for efficiency, while others rely on the high-precision event timer for consistency. They recommend checking the constant TSC flag in this proc CPU info file on Linux. If this flag is present, it indicates that the TSC runs at a fixed frequency across cores. However, be aware of potential variations due to power-saving features and machine states. Finally, they suggest targeting a specific chipset and operating system and reviewing the relevant documentation for detailed clock source information. For higher precision needs, consider using clock gettime with clock monotonic. Here's the tip I promised. Always use synchronization mechanisms when comparing time points across threads. This can help mitigate discrepancies and ensure your timing is as accurate as possible. And there you have it. Understanding how clocks work in multi-threaded applications can save you a lot of headaches. If you found this video helpful, don't forget to subscribe for more insights and keep experimenting with your code.